My name is Avery Bull. This is Lester Aguilar. This is Michael McNew and Jessica Morgan. And we are BAM. So earlier in Senior Design 1, we wanted to build something that could be used in mass production to grow plant for food for areas that don't necessarily have good land for agricultural use, or something that you could use that will reduce the hassles of gardening. Like maybe the water bill is just racking up, or maybe the dirt you're trying to use just isn't working, or maybe you're doing everything, but it feels like you're in a competition on who could kill the plants the fastest. So we decided to build a self-sustaining hydroponic system. This system, what it does is you have a reservoir of water, and there's going to be a pump that brings it up to PVC pipes with plants hanging on top of it. The water's going to naturally fall down through the pipes, and it's going to go through the roots of the plants, and the water will just eventually go back to the reservoir. We have our Arduino that's going to watch the air temperature, water temperature, the pH levels, which is basically the acidity of the water, and also the water level. The Arduino is going to turn on the dispenser if the pH level goes too high, with the solution to lower it down, and it's not going to affect the plant growth. And we have a separate dispenser that the Arduino is going to turn on once a day to put plant food inside the water, so that way the water is the plants are eventually getting food all the time. We try to make a system that's low maintenance. Whoever owns it only has to replace the water once a week, and all the parts, the lights, the fans, the pumps, and all the sensors, this can be found online anywhere you need to be, and the circuit's made in a way where all you have to do is just take the wire out, throw away the old part that's not working, put in a new one, put it back on there, and you're set to go. So that's our system. Do you have any questions? Yes, sir.
Did you take a study to see if the cost of using that would exceed or be less than regular plants growth?
A little bit. Again, you don't have to worry about any of the dirt. The amount of water that you have to use, you only have to use at max. The maximum amount you could probably use to do this is maybe 9 gallons of water each week.
Right. No, it was mainly the idea that you've got, it looks like 8 plants there.
Yes, sir.
If you had 8 plants in the ground, you know, how much would it cost to grow those compared to the 8 plants that you grow there?
I think the problem that we were addressing was if you're not unable to grow anything in the ground. If it's,
Okay.
you're literally not physically able to do it, boom.
And typically, we did this for size restriction for this, but generally when you have a larger system, you can grow dramatically more plants than you can in small. So, you know, if you're growing for multiple people, you're able to grow as much food or more food than you would per square foot than regular gardening. And so cost-wise, I don't have a number for you, but the upfront cost would be more, but over the long run, this is definitely going to outweigh typical gardening.
Have you done any test on the taste of food?
I love it. I actually, I do this at home. So my hydroponics vegetables, they grow bigger and
Fantastic.
well, to me, it's like, because I'm proud of it. But they grow larger, and the plants themselves typically look healthier, and they're a lot easier to take care of.
Are you going to take home the project with you?
I wish.
Yes, sir.
Yeah, I believe there was a hydroponics display down at Disney World where they had, you could go through, and they had quite a bit of hydroponics going on at that time.
Yes, that's one of my favorites.
Okay.
How do you ensure that the root systems of the plants are being interacting with the solutions that you're putting into the piping?
The-
Can you repeat that? I didn't hear you. What you said?
So how do you ensure, if I put a plant in there,
Yes,
how
sir.
do I ensure that my roots are being adequately contacted with these solutions?
Well, the cups are long. We try to get cups that are tall enough to where once it fits in the hole, no matter what size. I think there's only about a 1 inch difference between the bottom of the PVC and the bottom of the cup. And with that, the water is actually nearly touching the cup as well. So we thought, as long as the bottom of the cup is as close as possible to the bottom, the water would still reach the roots, unless the roots maybe probably about this tiny.
So do the pots have dirt in them?
No, what they do is we have little pebbles that keep the plant erect straight. That way, when it's up there, we don't have to worry about the plants moving left or right or anything. But the rocks is there to be sure the plant is still up straight and it actually won't move even if the water's under is rolling through the roots.
And there's holes in the net pots, so the roots are coming out, and as the water is just trailing past it, they're being fed, and so the top roots are actually absorbing the oxygen from the air. The bottom roots are absorbing the nutrients from the water.
Okay, let's thank the team.
Thank you.